Hey everyone, today we're going to talk more about similar triangles and proportionality. And the first couple examples are pretty self-explanatory. There's no theorems or anything to point out, so let's just dive right in. You want to set up your proportion by using the similar sides. So like 15's similar to 12, and x is going to be similar to 8. Okay, so you can set it up differently than I do, but you need to make sure you maintain the same order. So this is what I mean. If I go 15 over 12, that's using the left triangle over the right triangle. And, um, and then I'm going to write equals x over 8. So if you ended up writing something like 8 over x, that's reversing the order, okay? So you don't want to do that, because when you cross multiply and divide, you get something completely different. So the order doesn't really matter how you set it up as long as you make sure it's the same order. But again, I like to pair it up with the similar sides, the corresponding sides, I should say, and that's how it makes the most sense to me. But now it's just a process of cross multiplying 15 times 8, which is 120, and then we're going to divide it. So we have 120 equals 12x. So we're going to divide it by 12. And 120 divided by 12 is 10. And that's our answer. You can always go back and check by just kind of off to the side here. Just let's say we do just by dividing it, and it should equal the same thing. So this is what I mean. 15 over 10. I'm using the outside side, and then I'm going to write 12 over 8, the outside side over the inside side. 12 over 8. So 15 over 10 is going to get you 1.5. And then 12 over 8 is going to get you 1.5. So if your ratios match up, you know you did it right. That's just a way of checking your work. You don't really have to do that for every problem, but now you know. Okay, let's look at example 2. X is going to correspond with 5, and 12 is going to correspond with 8. And so let's just set it up using x over 5 and 12 over 8. Again, maintaining the same order. I'm going from the left triangle to the right triangle. Let's not overcomplicate things. So x over 5 equals 12 over 8. So now I cross multiply. 12 over 5 is 60. 60 divided by 8 is 7.5. And it's over. Again, you could check your work by going like 7.5 over 12. See what that equals. 5 over 8. See what that equals. But I'm just going to move on for the sake of time here. The newish piece of information to talk about today is this triangle angle bisector theorem. So we know an angle bisector is going to cut an angle in half. So when it cuts an angle in half inside a triangle, it's forming two smaller triangles. We got this triangle here in red, and then the triangle in the blue is my other smaller triangle. And you still have that one on the outside. So technically we have 3 triangles now. But the triangle angle bisector theorem just says to look at those 2 smaller triangles. So I'm going to use the proportions from Km and Kj. In other words, the side Km on the red triangle and Kj. And then I'm going to equal that to Lm and LJ. So for this example, this is what it's going to end up meaning. I'm going to start off. I'm going to trace my two smaller triangles from the bisected angle down here at R, and those are the two smaller triangles. So you're tempted to set this up. You're tempted to set this up by like maybe saying, oh, x over 6 equals 18 over 14. But I don't want you to do that, and here's why. 18 is, what's that from? That's for the big triangle. The triangle angle bisector theorem talks about the two smaller triangles. So don't use 18 because that's from the wrong triangle. Instead, we need to figure out what this side TS should be. So yeah, I know if this from here to here is x, then what about from T to S? Well, if the whole thing's 18 and that little piece is x, then this piece here is 18, minus x. Alright, so I'm going to use 18 minus x for my side and 14 for my other side, and that's going to be the two smaller triangles, okay? Alright, so let's just write that off to the side over here. Okay, so I got, let's see here, 18 minus x over 14 is going to equal, well, I did the side over, well, looks kind of like the hypotenuse, so, or the diagonal side, we'll just call it that. So I'm going to go x over 6. Or you could think that the top side over the bottom side equals the top side over the bottom side. And it's the same process now. We're going to cross multiply and divide, only we have a little bit extra steps to do. If I have an expression like 18 minus x times it by 6, we're going to have to distribute. Excuse me. Alright. And then x times 14 is 14x. So, excuse me, I gotta pause this and cough some. Oh, excuse me, sorry about that. I'm pretty congested this morning. Alright, anywho, I'm gonna distribute this 6. So 6 times 18 is 108. And 6 times negative x is negative 6x. So equals 14x. Alright, now I'll just get all my x's to one side, so I'll add the 6x over there. Cancel that out, and I get 108 equals 20x. Alright, so now I just need to divide both sides by 20. You know, I'll get a decimal answer, but that's okay. I get 5.4. Excuse me, sorry. All right, that's all I have to say about that one. Let's do one more example on the back. Okay, similar process, but it's actually even easier. Here I have my bisected angle at the top, and I'm given the sides of the smaller triangles already. I have one small triangle here, and I have the other small triangle there. Okay, so I can use the 15, the x, the 9, and the 6, just make a simple proportion and solve. So I got 15 over x, top over bottom equals, is it going to be 6 over 9 or 9 over 6? It makes more sense to say 9 over 6 because that's the side that corresponds, so keep the same order. 9 will correspond to 15. 6 will correspond to x. So let's cross multiply. 15 times 6 is 90. 90 equals 9x. So divide by 9. 90 divided by 9. That's not a very good looking 0. That's not a whole lot better, but oh well. It's 10. That's my answer. We're done with these notes. Hope you enjoyed it. Goodbye.